Hi, we have already learned how to solve partial circuits like these, right? Here the three currents are given and maybe we want to find the potential drop from A to B. We know how to do these kinds of questions. We are now going to learn about full circuits. We are first going to focus on simple circuits. Now what are full circuits? Circuits that look like this. No hanging branches. And if you notice, all the battery EMFs are given, all the resistor values are given, but we don't know any of the currents. None of the currents are marked. So we are going to learn how to solve these kinds of full circuits. Now, what does it mean that we are going to solve full circuits? It means we are going to find currents in every one of these branches, and we are going to use the battery EMF and the resistor values to do so. The usual method that people introduce to solve this kind of a question is called the voltage drop method, where we use Kirchhoff's voltage law. I have developed a slightly easier method that I call the zero potential method. I will introduce the zero potential method first. You will see that will make problem solving really easy. And after that we will come back and learn the voltage drop method, which is easy for certain types of questions. So first we are going to focus on the zero potential method. The zero potential method flows from a very simple observation. If you look at this 6-volt battery, what is that 6 volt? Is it telling you the potential here? No. The potential there? No. It is telling you the potential drop from the big side to the small side. The 6 volt is the potential drop, right? Not the potential. Similarly, I don't know what the potential at A or what the potential at B is. But for a wire, I know that the potentials must be the same, which means the potential drop must be 0. Similarly, if I look at a resistor, Ohm's law tells us the potential drop V is equal to IR. V is not this potential, V is not that potential, V here is the potential drop. So if you look at all of these three cases, we have information only about the potential drop, not about the potential. What does that mean? That means if I had 3 volts here, this also is 3 volts, right? Potential drop will be 0. But suppose I increase this by 10, I made this 13 volts, then this also I increase by 10, 13 volts, still the potential drop is 0. So potential at every point, if I increase or decrease by the same amount, all the potential drops will be the same. But the only information we have is potential drop, not potential. So that means I can keep on decreasing the potential or increasing the potential till at one point I make it 0, right? So if the potential in a circuit is not specified, there will be some circuits where sometimes they will tell you the potential. But in most circuits, potential is not specified. In such a case, you have the right to take one point, any point, and then choose its potential to be 0. Okay? Now, of course, you can choose one point and say its potential is 2 volts. But instead of 2 volts, choosing 0 will make problem solving easier. So I'm saying you can pick any point and make its potential 0. Okay? But remember, you can only choose one point. You cannot say, I'll make this potential 2 volts, that potential 0, this potential 3 volts. No. You can choose one point and decide its potential. Usually, I'm going to recommend that you decide its potential to be 0. Okay, so let us look at this circuit. Let us see how do people usually solve it. What do people say? Oh, the current through this resistor I must be V by R. Now what is V? R we know it is 5 ohms. What is V? 10 volts. So they take this 10 volts and divide by 5 and say the answer is 2 amperes. Is this correct? Actually the answer turns out to be correct, but the method is wrong. Why is the method wrong? Because 10 volts was this potential drop, the battery's potential drop. Does Ohm's law say battery's potential drop divided by the resistance value is equal to the current? No. This V has to be the potential drop across the resistor, not across the battery. Well, in this case, it will turn out to be the same, but we don't know that yet. So you cannot just say you have to do this V divided by that R, not this V divided by that R. So this method is wrong. Okay. Why do people do it? Because it gives you the right answer. But that means in a different question, you will end up getting it actually wrong, even the answer will be wrong. So let us learn the right way of doing it. Let me clear this up. So to solve this circuit, I'm going to find this current I. To solve this circuit, I'm going to find or choose one point as zero potential. Which point? Well, I can choose that, this, anywhere, right? I'm going to choose this point as zero potential. Remember, you can only choose one point. You cannot choose 2 points. But that doesn't mean you cannot derive the potentials of other points. This point was chosen randomly. I chose this. That's all, finished. I cannot choose anything more. But if this is 0, this is a wire, so all these points must have the same potential. So that must also have 0 volts. But remember, this was not chosen. This was chosen, that was derived. Same way, all these must have the same potential, so that point must be 0 volts. What about this point? Is that also 0 volts? No, this is not 0 volts. Why? These were all wires, one wire, but that is basically connected by a battery. You know that the small side, if it is X, the big side must be X plus 10 because it's a 10 volt battery. Now the small side's potential is 0, so the big side's potential must be 0 plus 10, 10 volts. So this point's potential is 10 volts. Now this is 10 volts, that is 0 volts. So the potential drop across the resistor is 10 minus 0, 10 volts. So we can now use this 10 volts and we get 10 divided by 5 is 2 amperes. Now notice this 10 is the potential drop across the resistor. Well, it is the same as the potential drop across the battery. In this problem it is. In a different question it will not be. So you must know what is the right way to solve in every case. So we found the potential drop across the resistor, divide by the resistance value. That gives us the current 2 amperes. Okay, here I chose this as the 0 potential point, right? But I can choose that. That's my choice. So let me now do this question again, but this time I'm going to choose this point as 0 potential. Wait a minute, this is a 10 volt battery. Can I call that 0 potential? Absolutely fine, you can choose any point as 0 potential, but only one point. Now if this is 0, is this 0? Is this 0? No, we have to derive the rest of it step by step. Well, if this is 0, the big side is 0 potential now, but the small side must be 10 volts less. So that means 0 minus 10. So this point must have 0 minus 10 minus 10 volts. Now if this point has potential minus 10 volts, all these are all part of the same wire. So that means this point must also have minus 10 volts. This is the same wire. So that point must also have minus 10 volts. Okay. Now that was 0. So we derived that this was minus 10. But if this is minus 10, this must be minus 10. That must be minus 10. All that is derived. This was the choice. Here this was the choice, here this was the choice. Only one choice. Okay. Now I want the potential drop from here to there. So because I want the current, let's say in this direction, so I want the potential drop to be in the same direction. So what is the potential drop in this direction? 0 minus minus 10. So that is going to give me a potential drop of 10 volts. So this is 10 volts, and so I can say 10 volts is the potential drop across the resistor, divided by the R value 5 gives me 2 amperes. So same answer. Here I chose this to be 0 potential. There I chose that point to be 0 potential. You see different points, but only one point. The rest are also 0 here, but that is not a choice. Those things were derived. Okay. So you can choose any point to have 0 potential, but only one point. So in this question, it looks like I'm making a big fuss about the problem because you see I could have directly done 10 by 5 and got the answer. But now we are going to do another example where if you take the battery voltage and divide by the resistance, you will get the wrong answer. And so you have to do it by using this method step by step carefully. Let us look at this example. Let us now look at this question. Here I have 2 batteries and a resistor. So if I were to use I equals V by R, R we know is 5 ohms. What is V? Suppose I chose this as V. This battery has 10 volts. Suppose I use that directly. I'm going to end up with 2 amperes. Okay? But I could have chosen this as the battery. So I could have said I is 4 volts divided by 5. I will end up with 0.8 amperes. Now which of these is correct? Actually, both are wrong. Why are both wrong? Because the V that we need is this V across the resistor. Okay, in the previous example, it didn't matter, you got the same answer. But you can see that right now, if you use this battery or you use that battery, you're going to get the wrong answer. So, you always have to look at the potential drop across the resistor. Only then you can use V by R. I is V by R. Let us solve this problem using the zero potential method. Now, I can choose any point I want as zero potential. I'm going to choose this point as zero potential. Well, if this is zero, that means this is a wire. This also is zero potential. Remember, there was only one point that was chosen. This was the choice. This was derived. Now, if this is zero potential, that must be how much? 10 volts. Why? The small side is zero potential, right? The big side must be 10 volts more. So, 0 plus 10, so that must be 10 volts. Here the small side is 0. The big side must be 4 more. So, 0 plus 4. So, this must be 4 volts. 10 volts, 4 volts. So, the potential drop in this direction is 10 minus 4, 6 volts. Now, the potential drop in this direction is positive. That tells us that the current will be in this direction. So, that must be the direction of the current. And how much is the current? V by R. Which V? Not this potential drop, not this potential drop, this potential drop. So, potential drop across the resistor. So, it is not even this potential. It is the potential drop across the resistor. So, 6 volts by 5, 6 by 5, that is going to give us 1.2 amperes. So, the current through the resistor is 1.2 amperes. If you notice here, I have one resistor and two batteries. What if I have one battery and two resistors? How do I solve this problem? Well, let us use the zero potential method again. I can choose any point I want as zero potential. So, but should it always be these corners? Not necessary. So, this time what I'm going to do is I'm going to select a point in the middle. So, I'm going to choose this point as zero potential. It's my choice. Now, if I chose this point, because there is a wire, that must also be zero potential. And this wire tells you this must also be zero potential. So, zero potential there and zero potential here. Okay. Now, if this is 0, that is the small side of this battery is 0, the big side must be 16 more. So, that means this point must be 16 volts. Okay, I got this point is 16 volts, I got that point is 0 volts. But what about that? Can I say 0 and that is 0? No, this is a resistor, it's not a wire. 16 volts, I can't say that because this is a resistor. So, what is the potential there? I don't know. Maybe we can call it X volts, but we don't know what is X. Okay, but how will then I solve this problem? I know this potential drop, but across both the resistors together. I don't know the potential drop across one resistor. No problem. Let us say that this has a current I. The same current is going to flow that way. So that means that current will also be I. So what is this potential drop? IR. So that is going to be 5I. What is this potential drop? I into 3. So that is going to be 3I. So I know this potential drop. I know this potential drop. So do I know this potential drop? Yeah, 5I plus 3I, that is the total potential drop. But this point is 16 volts, that point is 0. So what is the potential drop between these 2 points, right? From here to there, 16 minus 0. So 16 minus 0 is 16. So 8I is 16. And so that tells you I is 16 by 8, which is 2 amperes. So I found out that this current is 2 amperes. Okay. Now, could I have done that directly? Yes, I could have. I know that between this point and this point, the potential drop is 16 volts. But these two resistors are in series. So I could have combined them. I could have said, this is 5 plus 3, 8, right? This is a single resistor of 8. And across the resistor, it has a potential drop of 16 minus 0. So 16 minus 0 divided by this resistance, which is 8 ohms. So this is V by R. But remember, it is V across both of them together. So we'll use this also. So this also gives us the same answer. But generally, I want you to learn how to solve it by using I, because in certain cases, you may not be able to combine. but you will always be able to write an equation like this and solve. So I hope you have understood the power of zero potential method. So as you do more and more problems, you will understand this better.